we start the regression testing of the existing flowchart to see that the initial model is running correctly. We make sure that it behaves the way we expected. The static analysis is green. The dynamic analysis shows that all test cases are green. The structural coverage is 100%, including MCDC and design ranges. And we have a verification report showing us all of these metrics, including 100% of requirements coverage. This test quality is a good prerequisite for model refactoring, as we will be able to spot any functional regression. For our exercise, let's go to the variant subsystem with Flowchart implementation, copy, and rename it. We will build a state machine in Stateflow, SM. Let's activate the SM variant. Now we can rerun the verification. Static analysis is fine. The test cases are also green. And this is a good starting point for our refactoring. So, let's look under the hood. We have 2 inputs, 2 parameters, and an output. The interface remains unchanged. The required function is implemented as a flowchart. We now want to implement the same requirement by using state machine. I move the junction to disable the library link and to start modifying the model. And now we need a state object. Its name will be on. I use the capital letters for the state names. The condition action will be executed after entering the state. I might use the entry action, but I prefer the inner flow graphs because Stateflow animates the execution of it during simulation. I also connect the conditional transition to the on state. We will repeat it for the off state. Remove unnecessary transitions, add the state object, adjust the inner flow graph, connect the conditional transition. So, this is the part of the function that we need for the initial activation of the chart. And now the question is, how do we go between those states? We need some conditional logic for transitioning between the on and off states. And it happens to be the same logic as we need for the activation. Let's rearrange the states. I move the on state to the left. When the state flow chart will be executed the first time, and this condition is true, then the on state will be activated. Otherwise, a default transition shall be executed and the off state will be activated. Stateflow recognizes that this conditional transition is wrong. Well, let's connect it to the on state. As you see, we have a lot of assumptions here. Now, it is a good time to run our regression tests and see the results. We'll deactivate other verification methods, activate the EverTest debugger, and start the simulation. In a debug mode, we can run the simulation step by step. What you see here, in the first simulation step at time 0, we went into the off state. And this is exactly how we expected it. You can execute the next simulation step. The condition was tried, but it is not true, so the off state remains active. It will stay the same until the step 10. Now we are in the step 6, 7, 8, 9, 10. So, now the on state was activated. The animation was quite fast. Too fast to comprehend the dynamic behavior. Let's go to the Simulink Debug tab and set the Stateflow animation speed to slow. In the slow animation mode, we see exactly in which order the Stateflow transitions are executed and when the states are activated. Go to the step 10, and now we see what is happening. So the good thing is that we can prove based on expected output values that in this use case the model behaves exactly the same way as the previous one. How about the other test cases? This test case also will be animated, and it is green. And this other test case is also animated. This is what I love about Stateflow, the debugging with animation in a slow mode. Now we have a warning in EverTest that some steps with changing output values are not displayed in the test sheet. And we see that something unexpected happened over here at the step 80. Let's dive in, enlarge the number of steps, because now we are running the simulation with a step size of 1 millisecond. For the last test case, we see that the state chart behaves other than the flow chart. So now, we see the power of the regression tests. We could identify some specific parts which do not behave exactly the same way as they did before. Let us switch to the flow chart. If we now run this test case, it's all green. Just note, in a flow chart, the conditions are executed, starting from initial condition, in every single step. In a state chart, though, the execution starts from the currently active state. It makes a difference here. And now we switch back to the state machine that we just developed, run it, and it's not quite the same. Let's debug the implementation. In the first step, the diff signal is 0, and the ready flag is true. The state chart moved over to the on state. This is exactly how we expected it. Now, in this test case, The parameter off threshold is 0, and the parameter on threshold is also 0. It is an unusual use case as we develop the test case just for the coverage of design ranges. This edge case is the reason for the oscillation when the diff signal is also 0. The solution for this might be the change of the requirement, the change of the parameter design ranges, or the exclusion of these time steps in the test case. For now, I just exclude the test steps where the diff signal is 0. Now we see that our test case is green. Is it correct? Is it wrong? In a real project, you would need to discuss and decide in a team meeting how to resolve this uncertainty. Now, we have a verified implementation as a state chart. In the next exercise, we will generate C code for these different implementations. You will see how the models look like in C. To prepare the model for code generation, I'll run the EverCheck for it to see whether static analysis is also okay. Almost everything is fine. We can modify the findings automatically and run EverCheck again. Simulink checks are okay now. Stateflow checks are fine. For the code generation, I need to modify the function interface. Run it again. The function interface is fine. This is exactly how I will generate the C code for it. And for the traceability, I will also modify the comments. They will be automatically added to the block descriptions and will be available in the generated C code. Now I can run the complete check set. It looks good, except I need to activate the library link again. Oh, well, we'll actually need to break this library link connected to the existing Flowchart implementation and create a new library for this state machine. Let's rerun the checks again. Fine. So, let's activate all the verification methods and run everything in a batch test. Static analysis results. Green. All the test cases are running one after another. Green. The decision coverage and the MCDC are green. Coverage of design ranges. Green. The verification report is green. It shows us the verification summary.